1. Okay, everybody, today we're working on the second part of 7.3, and we're just continuing our study of finding 6 trig function values. And this is of any angle, no matter how big or small, positive or negative. So here are your essential questions. How do I find the trig values of any angle, given a trig value and a quadrant? So it's a little different today. A little more work on your part. And then how do you extend this to find values when the terminal side of the angle lies on an axis? All right, so let's start with just a little bit of information. You'll notice that the little left-hand line here for our margin is missing. Just go with it. Okay, I'm going to draw a little line. It's going to straighten out right there. Okay. All right, so we're going to start off with a little saying here to help you remember in which quadrant is a trig function positive or negative. So the saying goes like this. Let me gather my pen and not my intelligent pen. It goes like this. A smart trig class. Now, some teachers will tell you that it's instead of a smart trig class, that it's all students take calculus, but that's not true. But here is true. You are a smart trig class. Therefore, we're going to go with this one. So what does that mean, that little saying? Notice where I placed the A. It's in quadrant 1, and smart is in quadrant 2, like that. Okay, so in quadrant 1, here's what this means. All functions in quadrant 1 will be positive. Sine, cosine, tangent, and the reciprocals. Everybody's positive in quadrant 1. So A stands for all, positive. Smart starts with the letter S. And the trig function that starts with the letter S is sine. So in quadrant 2, your sine function will be positive, but your cosine and your tangent and the reciprocals will be negative. Trig in quadrant 3 starts with T. T is your tangent function. And so in quadrant 3, your tangent function will be positive, but your sine and cosine will be negative. And then, of course, in quadrant 4, C for class, your cosine will be positive. And so a smart trig class, it's just a little term or a little phrase to help you remember the placement of positive and negative trig functions. Okay, just another quick little review. I'm going to switch to black here. We know that this is quadrant 1, and in quadrant 1, your x is positive and your y is positive. In quadrant 2, your x is negative and your y is positive. In quadrant 3, they're both negative. And in quadrant 4, positive x and negative y. Now, these are all useful little tips, just reminders, because I know you know that. Okay? So, there's that. A couple other things. So, sine of theta, we know as opposite over hypotenuse. And yesterday, I introduced you to the concept of the y-coordinate over the radius. So I wanted to remind you of that. And let's talk about cosecant. That is not a C. Try that again. Cosecant of theta, we know is hypotenuse over opposite or radius over y, as long as y is not 0. Because you can't have 0 in the denominator, but your y-coordinate can be 0. Cosine, adjacent over hypotenuse, or your x-coordinate over your r. And of course, its reciprocal function, secant, which is h over a, or radius over x-coordinate, as long as x is not 0. And then, tangent of theta. Now, I'm going to introduce some extra things about tangent today, so clue into that because that'll make your homework a lot easier. Opposite over adjacent, or y over x as long as x does not equal 0. Why is that? Because it would make the function undefined. Yeah, you can't put a 0 in the denominator. Okay, cotangent a over o or x over y as long as y does not equal 0. All right, so that's good. Now let's go back and talk a little bit about tangent. Some other things to know about tangent. Tangent of theta is also your rise over your run, or AKA slope. So it's the slope of the terminal side of your angle, which is really useful, especially in calc. You're using tangent of curves all of the time, okay? It also could be considered change in y over change in x, dy over dx. Okay, so tangent's a lot of things, but I think it's really critical to start understanding that tangent is your slope. It's the slope of your terminal side. And if you're working on a coordinate plane and you're working on graph paper, it's easy to identify tangent. Okay, so there's that. One other thing that I want to talk about, two other things. Your reference angles. So yesterday we were talking about these massive angles, obtuse and reflexive. So like, for example, say I were to give you this angle here, right? And if it was in standard position, it would be this angle. Well, we were not using trig with that angle. What we were doing was dropping a vertical line and connecting the terminal side to the x-axis, and we were taking theta's reference angle. So that's theta sub r. Sorry, I know it's a little bit hard for you to see. Theta sub r is just the reference angle. So we were using this little acute angle and our opposite and adjacent and hypotenuse, or our y, x. And don't write that, please, because I'm going to do some other stuff in here. I was just indicating a little bit of stuff. All right, so when you're doing these angles on your coordinate plane, your reference angles should make a bow tie. So anytime you are working on a circle or you're working on a coordinate plane, you want your reference angle to be between the x-axis and the diagonal. Okay, it's an acute angle. And so you see your little bow tie here? These are going to be your reference angles. So these are your theta reference. We don't ever want to see, do not write this, just watch. We don't want to see you doing that. Okay? That's not a reference angle. Reference angles are always connecting terminal side to the x-axis. Okay? So we are always working off these angles here, from the terminal side to the x-axis. So you see the little bow tie? Get it? All right. One other thing. This is just a statement that should make sense. Radius is always positive. I don't know how you can draw a circle and measure the radius and tell me it's anything but positive values. You can't tell me it's 0 units long, and you certainly can't tell me it's -2 units long. Radius is always positive. Okay? Your x's and y's can be positive or negative depending on your positioning on the coordinate plane, but radius is always positive. Okay, so here we go. So the notes for today are going to go like this. I'm going to do an example, and then I'm going to stop the video while you practice. And I'll give you 5 minutes to do a problem. Then we'll come back together. We'll see how we do. Okay, so I'm going to do one. You're going to do one. That's how we're going to do it. So let's look at example 4. Picking up from yesterday's example 3. Here we go. The terminal side of an angle theta, which is in standard position, lies on the given line and in the given quadrant. Find the sine of theta, cosine theta, tangent of theta. Okay, so the angle is in standard position. And the angle is lying on, or the terminal side is lying on that the line in the given quadrant. So let's just take a little bit apart. Now I told you tangent of theta was slope, rise over run, right? So could we remind ourselves that y equals mx plus b? That m is your rise, your slope is your rise over your run, which means your slope is your tangent of theta or tangent of beta, whatever we're labeling the angle. You with me? I just talked to you about that. Okay? And we're in quadrant 3. So let's just get as much information about quadrant 3 as we can. What do we know about the x coordinate in quadrant 3? It's negative. And how about the y coordinate? Okay, so we know our x and y are negative. Also, a smart trig class, which function is positive down here in quadrant 3? So we know our tangent is supposed to be positive, which means our sine value will be negative, cosine value will be negative. So this is what I know. So how about we graph this line in quadrant 3 by finding the slope, the y-intercept. Okay, so subtract 3x. So negative 2y equals negative 3x. I'm going to go ahead and push that plus 0 out. That's your y-intercept. So we know we're going to be hitting the origin. Divide by negative 2. Divide by negative 2, everything. So we get y equals 3/2 x plus 0. So tell me, what's the tangent of theta? 3/2. Right? It's the slope. So this is my x, this is my y, and this is my x, right? Change in y over change in x. But I'm in quadrant 3. So really my y is negative 3 and my x is negative 2. So negative 3, no, my x is negative 2. So negative 2, negative 3 is a point on the terminal side of my angle theta because it has a slope. So I'm going to just go, okay, 1, 2, 3, and negative 1, 2. And I'm going to go ahead and plot that point. We're just doing a sketch here. I think I will go back and actually draw a line. And then I'm going to draw a circle, and hopefully it'll come out pretty good. It's not because I had a little skip. I'm going to try that again. Okay. So I just want my circle to pass through that point. All right. So there I have it. I have angle theta. Here's angle theta. It's this big, massive angle right here from standard position. But I can't work off of that, right? So I do my reference angle. So what do I connect this point here to make my reference triangle or my reference angle? The x-axis. Okay? So here is theta's reference angle. So I'm going to work off of that angle. So here's what I know. My opposite of theta reference is negative 3. My adjacent is negative 2. And my hypotenuse, which is also my radius, right? Because it's the radius of my circle, is unknown. Questions about how I got there? So we need to find our radius, don't you think? So radius is equal to the square root of negative 3 squared plus negative 2 squared. Persevere. That's just 9 plus 4. So the square root of 13. So now I'm just going to organize my data. Here's what I know. My x is negative 2. My y is negative 3. And my radius is the square root of 13. And I need to find my sine, cosine, and tangent of angle theta. So sine of theta Thank you. Excuse me. Sine of theta is O over H, right? Opposite over hypotenuse. Or Y over R. Well, I'll just write that over there. Y over R. Okay? So we'll just simplify that. Rationalize your denominator. So sine of theta is negative 3 square root of 13 over 13. And there's your sine. Questions? So cosine. Cosine theta, x over r. We organized our x and r material information right here. So that's negative 2 over the square root of 13. Rationalize. How many of you are starting to rationalize in your head? Right? For sure. So negative 2 square root of 13 over 13. And then tangent of theta, look, we already know that. It was the slope of our line, y over x. Negative 3 over negative 2, which is just 3 over 2. And there you can see the slope opposite over adjacent. Okay, and so questions? So I'm going to have you do problem number B. I'll give you 5 minutes. I'll pause the video, give it a go, come back and see if you got the answer right. Okay, and so there are your answers for part B. If you did something wrong, take a look at my work, make your corrections. We are moving on. So on to the back side of today's notes. This is example 5 here. And actually, I think this one's probably a little bit easier than the others because it's telling you your tangent already. And it's telling you what quadrant you're in. You don't have to solve an equation to find your slope. It's telling you what it is. So given that tangent of theta is negative 2/3 and theta is in quadrant 2, okay, in quadrant 2 your sine should be positive. Everything else, see, tangent's negative, so that's good. Find your other 5 function values. So I say, let's figure this out. So here's what we know. Tangent of theta is negative 2/3, and in quadrant 2, your x is negative and your y is positive, right? And it's change in y over change in x. So I guess we'll assign the negative to the 3, right? So we're talking about this point here, and the positive to the 2. So that would be the point that we would be graphing, negative 3 and up 2. And here's angle theta, right? So that's theta. So here's theta's reference angle. We can take a point, our point on the terminal side, connect it to the x-axis. So here's our reference angle. So here's our opposite, our adjacent. Nope, that's not adjacent. Let's try that again. Opposite, adjacent, hypotenuse, or y, x, and radius if we were to draw a circle. I'm going to go ahead and leave the circle off of that for now if you don't mind. Of course, you could sketch one in if you like. So we're going to work off of this reference angle down here. So here's what we know. Y is 2. I'll get a different color here. So y is 2. X is negative 3. And I think we've already found this radius just on a different a triangle that was oriented a little differently. So radius is equal to the square root. Yeah, 13, because it's 2 squared plus negative 3 squared, which is 4 plus 9. So our radius is still the square root of 13. So our sine, cosine, tangent, those are all just going to be some form of the problems that we just solved. So let's organize that information. Do you want to organize it x, y, r? X is negative 3, y is 2, and our radius is the square root of 13. There we go. So sine theta is y over r, recall, or opposite over hypotenuse. So that's 2 over the square root of 13. I think we can just write that as 2 square root of 13 over 13. And while we're at it, since we have to do the reciprocal functions, cosecant theta would be r over y. So that would be the square root of 13 over 2. 2 down. Cosine. Notice sine is positive, by the way, supposed to be. So cosine theta. That's your x over your radius, or your adjacent over hypotenuse. So that would be -3 over the square root of 13, or -3 square root of 13 over 13. Secant theta, r over x, that would be negative square root of 13 over 3. Well, it's a -3. Square root of 13 over -3. I just put the negative out in front. I was kind of dividing in my head. Positive by negative is negative. But yes, tangent we already know. Tangent of theta is -2/3. So cotangent should be no problem. -3/2. So I think that one turned out to be quite a bit simpler, because you didn't have to graph some line and figure out what your tangent was. You were told what that was. All right, questions? Okay, so now we're going to go into this, the terminal, when your terminal side is on an axis.
Just give a breakdown.
Okay, and so let's go back and talk about what a quadrantal angle is. Quadrantal angle is an angle in standard position whose terminal side lies on an axis. Okay, and so down here in example 6, I'm asking you to find the sine, cosine, and tangent values for 90, 180, 270, 360 degrees. And all of these in example 6 are examples of quadrantal angles. Okay, you can see the terminal side is lying on either the x-axis or the y-axis. So sometimes these things get tricky. So what I'm going to do is I'm going to go online to an online circle here. And I'm going to zoom out just a little bit so we can see the whole circle. And bring that up just a little bit. All right, so the opposite, adjacent, and the hypotenuse kind of went away from my screen, but here I have a unit circle. You'll notice that the radius is 1, and so if we are going to take the terminal side all the way to 90 degrees, notice what's happening to my x-axis, or my x-coordinate. It's getting smaller and smaller, and my y-coordinate is approaching 1. So when I get to 90 degrees, let's see, I can only get close with this. That's pretty close. You can see that your x-coordinate has completely disappeared. It's 0. There is no opposite. Your y-coordinate is 1, and the radius is also 1, because that's from the center to the edge. And so let's go back here to our picture, and what we see here is here's our x-coordinate, here's our y-coordinate, and our radius is also 1. And so I pretty quickly can decide what the sine of 90, the cosine of 90, and the tangent of 90 is based upon that information. Remembering sine is y over r, and our y-coordinate is 1, and our radius is 1. Therefore, the sine of 90 degrees is 1. Cosine of 90 is the x-coordinate over the radius. Our x-coordinate is 0. Radius is 1, so the cosine of 90 is 0. Then the tangent of 90 degrees is your y over your x. Okay, so that would be 1 over 0, which is undefined. And you can look at the slope of that line there. That's definitely an undefined slope. And so there you go. Let's go back to the interactive circle over here online and look at what happens when we approach 180 degrees. So as I continue to spin around here, you can see that my x-coordinate is starting to expand, my y-coordinate is starting to get smaller and smaller, and as I approach 180 degrees, there I go, I hit it exactly. You can see that your x-coordinate, it's hard to see here, is at -1, Your y-coordinates disappeared. It's at 0. But your radius is always 1. So we'll go back to the picture here, and we'll note at a 180-degree quadrantal angle that our radius is 1, our x is -1, and our y is 0. So your sine of 180 degrees, y over r, is 0 over 1, so that's 0. Cosine of 180 degrees is x over r, that's -1 over your radius 1, that's -1. I'm going to clean that up, -1. And then if you look at the tangent of 180, I would like you to look at the slope of that line. That's a flat 0 slope, and that's your y over your x. So that is a 0 over 1, which is 0. So what I'd like you to do now is go ahead and finish up these other two quadrantal angles, 270 degrees and 360 degrees. So press pause, give it a go, see how you do, and come back to the video and finish it up. And there you go. And so your sine of 270 was -1, cosine was 0, and your tangent was undefined. And for your 360-degree quadrantal, your sine of 360 was 0, cosine was 1, and your tangent was also 0. Okay, and so now what we're going to do is expand this information that we've just learned here to coterminal quadrantal angles. So like, for example, here, on this problem here, it's asking us to find the sine of -90 degrees. And so if we're working this direction, this is -90 degrees, well, coterminal to that would be 270 degrees. So we could say that the sine of -90 is equal to the sine of 270 degrees, and the sine of 270 degrees we found already up here was -1. And so there you have that. This is the nice thing about knowing coterminals. All right, here we have cosecant of 540. Now cosecant's the reciprocal of sine, so we'll have to use the sine of the value and then flip it, but let's see how we do. Let's just find coterminal to 540 by taking 540, subtracting 360, and that gives us 180 degrees. Okay, so that works out pretty good. So cosecant of 540 ends right here after one full revolution and then returning back. So that's 540 degrees. And so we could say that the cosecant of 540 is equivalent to the cosecant of 180 degrees. And so I think what we'll do is we'll go ahead and grab the sine of 180 degrees, which was 0 over 1. And then we'll just go ahead and write the cosecant of 180 degrees, which is 1 over 0. And so we could say that the cosecant of 540, which is equivalent to the cosecant of 180, is undefined. And there you go. So your homework tonight on problems on a 7.3 assignment. Let me go back and look. It's on the other page here, so let me just open this up and I'll quickly get this for you. Okay, homework tonight is problems 29 through 37, 53 to 40, 57, and 63 to 69, but only do the odds from each of those question groups. Just do the odds. Okay, have a good day.